We need two types of address for communication, MAC address and IP address. Question is why we need two types of address. So let's suppose I have this PC1 whose MAC address is A and PC2 whose MAC address is B. Can these two PC communicate with each other with the help of MAC address? Is it possible or not? So yes, it is possible. Yes or no? Then why we have IP address again? Or let's suppose this machine have only IP address 10.1.1.1 and here IP address is 10.1.1.2. So these two devices can communicate with each other with the help of IP as well. Means only IP or only MAC. Yes, it is possible. Both have address. So we can design the operating system or protocol in such a way so that these two devices can communicate with the help of either MAC address or with the help of either IP address. But we are using two types of address, right guys? So just assume if we are communicating these two devices with the help of MAC address, right guys? And let's suppose both devices is connected with one switch. So switch need to maintain one table for PCA also and for PCB also. This switch is connected with router. Now router also need to maintain a table for both PC. So this time how router is going to forward traffic to this PC on the basis of MAC address only. So router have to install both MAC address in their table, right? So if I have two computer in the LAN, router need to install two entry. If there are 100 PCs are there, then router need to install how many entries, guys? 100 entries. And then this router is connected with internet. And like this, how many network are connected with internet? Lakhs of network, correct guys? Lakhs of network, correct? And in the lakhs of network, let's suppose there are only 100 user. So this router on internet need to maintain how many entry? Yes or no? So database is going to be very large, yes or no? Which is again impractical, yes or no? So we cannot maintain the database if all devices are communicating with each other through MAC address only. Means each device on the internet need to have information of each device, correct? Like this internet router should have information that whenever I need to forward traffic to either PCA or PCB, I need to forward it from this interface. Like this there are lakhs of network. So for all lakhs of network, for all 100 user in each network, router need to maintain a database, which is not practical. That's why we have what guys? Logical address, IP address. So on the PC now I am going to define one IP 10.1.1.1, 10.1.1.2. Again router need to maintain how many entry in table? Two. You are thinking one for PC1, one for PC2, but this is not true. See, there is some common between computer A and computer B. What is that common? Common is both are member of same IPv4 network, right? So network ID of these two IP addresses 10 dot, let's say 0.0.0. So router is going to install only this network in their routing table. Let's say this is 0/0. Means 10.0.0.0 network is connected on what? Fast Ethernet 0/0. Whenever router will receive traffic, it will compare the destination. If destination belongs to this network, it will forward from this interface. Getting my point? So guys, now you are going to learn how to find the network ID, what is IP address, what is MAC address. Hope this is clear why we have two types of address. Why we have MAC address? for LAN communication. For LAN communication. Router never forward traffic on the basis of MAC address. Router forward traffic on the basis of what, guys? IP address. And switch forward traffic on the basis of MAC address. Hope these things are clear to you, very clear to you, right? So for, guys, LAN communication, we have MAC address. For communication between different network, we have IP address. Okay. And if this router need to forward traffic to, let's say, PC1, so this router need MAC address of PC1 as well. So only your router is going to maintain one table where it will store MAC address with IP address. That is what ARP table. Yes or no? ARP table, where router will have entry like the IP address 10.1.1.1 is using MAC address A. The IP address 10.1.1.2 is using MAC address B. Correct? But the internet router which is connected with router number 1 will not have this table, guys, and this router don't need to maintain this table, because this router, ISP router, will have only one information, that if I need to forward traffic in this network, I will forward it to router number 1. So this router need only MAC address of router 1, right? So in the routing table of internet router, there will be this network and MAC address of PC1 in the ARP table. Okay. So let's suppose I need to connect these all computers together. I need a centralized device. That centralized device is switch. So guys, through switch, I can connect these all computers together like this. And hope this is very clear to you how these PC are going to communicate with each other, means how switch is going to forward traffic. Yes or no? PC 1, PC 2, PC 3 and PC 4. PC1 MAC address is 0A, PCB MAC address is 0B, PCC MAC address is 0C, and PCD MAC address is 0D. So switch is going to maintain MAC address table to forward traffic. And guys, in MAC address table there will be entry for each devices, like on their 0/1 interface. Let's say a device is connected whose MAC address is 0, whose MAC address is 0A. Like this, there will be entry for all the devices. On 0/2 interface, a device is connected whose MAC address is 0B. On 0/3 interface, a device is connected whose MAC address is 0C. On 0/4 interface, a device is connected whose MAC address is 0D. And which type of port these are? It can be Ethernet, it can be fast Ethernet, it can be Giga Ethernet. And which type of cable these are? Which type of Ethernet cable these are? Straight through or crossover? Straight through. Right? So what is MAC address? MAC address, yes, also known as by physical address. It is also called as physical address. Then it is assigned by vendor, or we can say what, manufacturer. Correct. Then how long this address is, guys? It is an 48 bits address. Try to understand each point very carefully. Okay, because as I told you, MAC address is responsible for LAN communication. That means whenever you are going to design a LAN, or whenever you are going to troubleshoot a LAN, MAC address is going to help you a lot. Right? So it is 48 bits address and represented in, how we represent MAC address? In hexadecimal. It is represented in hexadecimal. Now question is, what is hexadecimal? 0 to 0 to F. No, 0 to F. One second. Okay, so what is hexadecimal, guys? Hexadecimal is type of number system that has 16 values. You can say base values equal to 16. So how many base values we have in hexadecimal? 16. 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E and F. Right? Clear? Hexadecimal is a number system that have 16 base values, 0 to F. Okay, to represent one hexadecimal number, how many bits is required, guys? This is important question. Question is, to write one hexadecimal, how many bits is required? No. Incorrect answer. See, if you have 2 bits, so your bits can be, if you have 1 bits, then bits can be 0 or 1. That means you can represent how many number? 2. Right? If you have 2 bits, then you can represent how many number? It can be 0, 0, 0, 1, 1, 0 or 1, 1. You can represent 4 values. Right? If you have 3 bits, so it can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Yes, correct. But here you have how many values? 16 values. So you need 4 bits. You need 4 bits. 4 bits to represent one hexadecimal. Right? 4 bits are required to represent one hexadecimal. So as this 0 is in hexadecimal, that means Binary will be what? 0 0 0 0. Correct. 1 means 0 1. Right. 2 means 3 means 4 means 0. 5 means 0. 6 means 0 1 1 0. 7 means 8 means 9 means 10 means 1 0 1 0. B means 11. 1 0 1 1. C means 1 1 0 0. D means 1 1 0 1. E means 1 1 0. And F means all 1. Okay, so this is the binary to hexadecimal conversion. Clear to all? To represent one hexadecimal, guys, we need 4 bits. If all bits are 0, then you will get what hexadecimal value? 0. Okay, so we represent MAC address in hexadecimal. And as I told you, it is 48 bits address. That means how many hexadecimal character are there? To represent one hexadecimal character, I need 4 bits. Right? And total length of MAC address is 48 bits. That means how many hexadecimal character are there? 48 divided by 4, right? 12. So if we have 12 character, guys, in hexadecimal, and each character carry 4 bits, that means how many bits we have total? 48. Correct? Is it clear? Right? So tell me, what can be my lowest MAC address? My lowest MAC address can be 12 times 0. This is my lowest MAC address, right? A smallest MAC address. What can be my largest MAC address? 12 times F. Correct. That means all MAC address is going to lie between this range. Yes or no? This is a smallest MAC address, a smallest, and this is going to be what, guys? Largest MAC address. Correct. All MAC address is going to lie between this range only. And is this MAC address correct, or is this MAC address correct, guys? Answer is yes. Right? Now representation can be different in the different vendor. Like you can represent this MAC address like this: 00 dash 00 dash 00 dash 00, like this. Or you can represent it like this also. Right? In both MAC address, in this MAC address and this MAC address, we have, guys, again 12 characters, and all are hexadecimal character, means both are 48 bits address. Right? Representation can be like this also. Getting my point? So guys, Windows operating system have different representation of MAC address, and Cisco IOS have different representation of MAC address. If I will talk about the representation of MAC address in window, so you can check it in CMD. Now this is my window operating system. Here I can say ipconfig all. So are you able to see the MAC address representation? How we are representing it like this. How many characters are there? 12. Let me copy this MAC address. And guys, is this MAC address lie in this range? Answer is yes. Correct. This is also one MAC address. This is also one MAC address on each NICs. Even NICs assigned or non-assigned doesn't matter. Will have one MAC address because MAC address is assigned by manufacturer company. At the time of manufacturing, they have hard coded this address on NIC, on network interface card. Right? If you want to see MAC address representation in Cisco IS, simply you can open packet tracer and you can check MAC address on, let's say, router interface. So this is my router. Let's suppose here I'm going to design one network. Switch. This is router 1. I'm saying R1. This is switch 1. I'm saying S1. This is switch 2. I'm saying S2. Which type of cable I will use to connect switch and router together? Crossover or straight through? This is a straight through cable. But I have automatic cable also here. So I am using automatic, guys. So it will sense the link automatically. Now on this router I want to find MAC address. So see, this router have how many interfaces now? 2. One is fast Ethernet 0/0. What is fast Ethernet? One of you had asked this question to me in, I think, day 1 class. What is fast Ethernet? Or in day 2 class. So I am expecting now this is clear to you. Like, what is fast Ethernet? Fast Ethernet is type of Ethernet cable with 100 Mbps bandwidth. Right? For 100-meter distance. So on 0/0 I want to see the MAC address. So simply I will give input here. So I am saying show me the interface. Yes, fast Ethernet 0/0. Show me the configuration of fast Ethernet 0/0. So it will show me the MAC address. Yeah. By default router interface are disabled. So this is MAC address, guys, of this interface, fast Ethernet 0/0. Is this MAC address lie in your range? In this range? Answer is yes. Right? So how we are representing MAC address in Cisco IS? This means we have how many fields? 3 fields. Each field carry how many bits? Oh my god, 4 characters are there, bits. One character means 4 bits. Each field carry how many bits? So let me write here some point. See, in Cisco IS, in Cisco, let's say, operating system, we represent MAC address in 3 fields. Each field carry how many bits? See, how many characters are there in one field, guys? 4. And one character carry 4 bits. That means total number of bits in one field is 16. Each fields carry 16 bits, right? And we separated the field with dot. Dot. Clear? Is it clear to everyone? So now if someone will ask you what is MAC address, so MAC address is a 48 bits physical address of a device, or you can say of a NIC, network interface card. We represent MAC address in hexadecimal. Hexadecimal is nothing but a number system where we have 16 base values 0 to F. So as we have 16 characters in hexadecimal, we need 4 bits to represent hexadecimal value. Okay. So tell me, can anyone tell me the MAC representation in Linux operating system, guys? How we represent MAC address in Linux or any other operating system? In Linux OS. Like this. Same like Windows operating system. This is also one representation of MAC address. And even you can represent like this also. Okay. So if here I'm writing two MAC address, guys, one is let's say 00 A, and my second MAC address is there any difference between these two MAC address? Answer is no. Answer is no. Now next thing, how MAC address is globally unique? Before that, do you have any question? Anyone have any question, guys, in MAC address? It should be clear to you all, right? Then guys, only I can teach you switching and routing. No, no, interface no. If you are purchasing a computer, brother, from the market, your computer comes with MAC address. MAC address is already, yeah, yeah. What is question? Okay, here you can see in the Cisco operating system we have three fields, right? Each fields have how many character? Four character. Four character. One character carry how many bits? 4 bits. So 4 multiplied by 4 is equal to 16. So total number of bits in first octet or first field is what? 16. Over here also 16. No, no, not. How interviewer is going to ask you question? Wait, wait a second. 16 bits, 16 bits plus 16 bits, 48 bits. So interviewer can ask you like, they can write down two MAC address like this, and they can ask you like, is there any difference between these two MAC addresses? They can ask you the length of MAC address, MAC address representation in Cisco operating system, or if you are applying for a job in, let's say what, in the Palo Alto, so they can ask you the MAC representation in Palo Alto, how MAC address is in unique, right? Each character carry how many bits in MAC address, representation, length, use. anything they can ask you, right? Now question is, guys, how MAC address is globally unique? So there is one organization who is managing MAC addresses and public IP addresses, right? To make MAC address globally unique, definitely we need an organization who will have record for each devices, correct? Otherwise, let's say I am manufacturing a computer, I'm a manufacturing company, right? I'm running a manufacturing company where I'm constructing, let's say, mobile phone. So mobile phone also need what? MAC addresses. So this is not like I can use any MAC address. I know this is the range of MAC address, I will assign one MAC address from the range. No, no, no. First I have to purchase some part of MAC address from a organization. That organization is INA, IANA, Internet Assigned Number Authority. Internet Assigned Number Authority. So let's suppose there are two organizations. One is, let's suppose, Dell, and the other organization is, let's suppose, IBM. IBM. Hope both companies familiar to you all, right? Guys, both companies are going to manufacture computers or any networking devices. So both companies need what? MAC addresses for their NIC. So first of all, both are going to request to INA. Not for the complete MAC address, for half part of MAC address. So first thing that you need to keep in mind over here is we divide MAC address into two parts to make it globally unique. We divide MAC address into two parts to make it globally unique. First part is known as OUI. OUI, and second part is known as vendor assign, right? So total length of MAC address is 48 bits. That means we divide it equally. That means OUI is how many bits? 24 bits. Tell me, guys, 24 bits, yes or no? And vendor assign is also 24 bits. So to configure a MAC address on NIC, a vendor company need first what? OUI. OUI. So let's say they'll have purchased one OUI from INA, and their OUI is this one, 000000. How many bits are there? 24 bits. Yes or no? Because how many characters are there? 6. And each character carry 4 bits. So 6 multiplied by 4, 24 bits. Am I right? So this is OUI of Dell. Now INA have one record, right, that I have already sold one OUI, which is 000000. I have already sold this OUI. Now after some time, IBM is also going to request for one OUI to INA. So maybe INA is going to provide this OUI to Dell, that is 01. Both OUI are different or same? Different, right? And INA have record that I have already sold this to OUI. So if third vendor company is going to request for OUI, INA will provide next IP address. Maybe it can be 000002, right? Correct, guys? Last OUI will be what? FF, this one, right? Now how Dell is going to manufacture computers? So to their first computer, he is going to assign one MAC address to their first NIC. That is going to be what? 0000, which is OUI, and then their own 24 bits MAC address that can be 000000, 1 or 0 as well, right? This is going to be what, guys? First MAC address of Dell. In the same way, second MAC address, OUI is going to be same, 000000, and then 000001. What will be the last MAC address of Dell with this OUI? 00. Last MAC address is going to be 00. What happened? Why it's not working? Yes, 000000FF, right? That means Dell can manufacture how many computers, guys, with the help of one OUI? With the help of one OUI, Dell can manufacture 2 to the power 24 computers. 2 power 24, right? So after 2 to the power 24 NICs, again they'll have to purchase what? OUI. And now in the next thing, IBM. How IBM is going to assign first MAC address to their NIC? So their OUI is this one 000 colon 01. So their first MAC address is going to be 0000 colon 01, and after that their on 24 bits, right? So see, the first MAC address of Dell and first MAC address of IBM, vendor assigned part is same, yes or no, right? But OUI is different. This is why both MAC addresses are unique, right? For second MAC address, IBM is going to be put OUI, same OUI 01, then 000001, right? So see, in second MAC address also, guys, their vendor assigned part is same, but OUI is different. That's why both MAC addresses are unique. So is it clear how MAC addresses are unique globally? And what OUI means? Organizational unique identifier. Who is going to identify the organization? So INA have knowledge that this OUI is for Dell. This OUI is for Dell, and this OUI is for IBM. This is for IBM, this is for Dell, right? So how INA is identifying the organization, guys? With the help of OUI only. Clear? So interviewer can ask you this question also, like how MAC addresses are globally unique with the help of OUI. And who is managing OUI? The organization like INA. Internet Assigned Number Authority. You can learn more about the INA on Google. Fine, but this is sufficient for CCNA. Now next type of address is IP address. And again, before starting the IP address, as I am telling you again and again, MAC address is important. If you have still any question, guys, please ask in MAC address. Otherwise, I will move to IPv4 addressing. Clear to all? Yeah. Switch port. No, no, switch port don't have MAC address. Switch learn MAC address of PC on their port. This switch is going to learn MAC address of PC1 on this port. Yes, router will have a separate MAC address for each interfaces. And this switch will have one base MAC address. Base MAC address means one switch have one NIC. 4 base MAC address means every switch will have one base MAC address. Getting my point? Like guys, on this switch, simply you can check the base MAC address of this switch is what? So version. Are you able to see base MAC address? Got it? Router interfaces have MAC address, na brother? This interface have one MAC address. See, this router have two MAC address. So interface fast Ethernet 0/0 and say include BIA. So this is MAC address on 0/0 interface, and this router will have one MAC address on 0/1 interface also. See, both MAC addresses are unique or not? Both are unique. Is OUI unique, guys? Is OUI unique? No, OUI is same, you can see here. Right? That means both MAC address belongs to same organization. Correct. Yes. If OUI is same, that means both MAC addresses belongs to same organization. Yes or no? Because OUI is the first 24 bits which tells about the organization, which identify the organization. Correct. And yeah, that is different thing. We'll talk about that MAC address later. Leave it for now. Right? So that is capability of switch. You know, with the help of base MAC address, which is going to find one logical virtual MAC address for their all interfaces. Right? On the switch, we didn't hard code any MAC address on their interface. Okay, we only hard coded one base MAC address on switch. On the basis of that, switches are automatically going to calculate one MAC address for their interfaces. Means one MAC address for one interface. That is different thing. Yes, on the router, manufacturer company had hard coded the MAC address. On the switch also, but on switch, single MAC address is hard coded. That is base MAC address in the operating system. On the router interfaces, we have hard coded address, hard coded MAC address. Now the next type of address is IP address. Any other question? No? Hmm? Now, next topic is IP address. IP, again in the IP we have guys two version, IPv4 and IPv6. For now I am talking about IPv4 addressing. Now points about IPv4 address. It is a logical address, that means changeable. Like as I told you, my physical address is globally unique. There is only one place all around the world, right? This is globally unique. My place is globally unique. But my name is not globally unique. Maybe other person are also using same name. So IP address is similar like that, logical address, and it is changeable. If you want to change the MAC address, you have to change an IC card. Okay, so MAC IP address is a logical address. It is 32 bits address. Length of IPv4 is 32 bits address. How we represent IPv4 address? It is represented in dotted decimal. How we represent it? In dotted decimal. We have 4 fields. Each field is separated with dot. Yeah. Okay guys, so now you tell me, if I have a 32 bits address and we divide it into 4 field, right? So each field carry how many bits? Each carry 8 bits. So each fields carry 8 bits, right? Now by using 8 bits, what minimum decimal value you can represent and what maximum decimal value you can represent? So if you have 8 bit, so 8 bit can be either 0 means 4, 5, 6, 7, 8 means all bits are 0, and maximum value is going to be what? If all bits are 1, then I will get what? Maximum value. So I'm expecting you all know binary to decimal conversion. Is there anyone who don't know guys binary to decimal conversion? Anyone who don't know how to convert a decimal value into binary or a binary into decimal? If there anyone, please let me know, because again this is very important. Binary to decimal. Like, can you tell me what will be the binary of 10? 1010, yes. So actually this is 2 to the power 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Yes. So actually we have this formula: 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 7 to 7. That's it. How many bits we have? 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So 2 to the power 0 is going to be what? 1. 2 to the power 1 is going to be 2. 2 to the power 2 is going to be 4. 2 to the power 3 is going to be 8. 2 to the power 4 is going to be 16. 2 to the power 5 is going to be 32. 2 to the power 6 is going to be 64. And 2 to the power 7 is going to be 128. Right? So if I have a binary like 0, 0, 1, 0, 1, 0, 0, 2, 4, 6, 7, 8. So what will be the decimal value of this binary? How to find it? See, on the first position 2 to the power 0 is on or off? On. 1, that means 1 here, plus. Second position guys, second position is on or off? Off, right? So we are going to ignore it. Third position 0 means off. Fourth position 8, right? This is on, so 8, plus. Fifth position off. Sixth position 32. Seventh position 0. Eighth position 0. So you can add this value 41. 41. So 41 is the decimal value of this binary. Clear? Is it clear? Okay. Here I can, you can make one chart like this, that if all bits are 0 0 0 0 2 4 2 4 6 7 8, then decimal value is 0, then decimal value is going to be 1, right? So you can even download one image for it, binary to decimal, binary to decimal with, let's say, 8 bits. So this is your formula. Copy and let me paste it over here, this one. Okay, then you can follow this chart. This is for hexadecimal, right? If you have 4 bits, for 8 bits this chart is fine. Copy it and let me paste it over here. Yeah, yeah. Why MAC address is 48 bits? This one, I think this is good. Bind it to decimal. Is it visible, guys? So if all bits are 0, then you will get 0. If one last bit is 1, then 1, right? So you have to practice this formula. Okay, so if you will convert this binary, if all bits are 0, then you will get what decimal value? 0. If all bits are 1, then you will get what decimal value? 255, right? That means, as I told you, my IPv4 address is 32 bits address represented in dotted decimal, and we have 4 fields, and each fields carry 8-bit information, right? So by using 8 bits, the minimum value which I can represent is 0, the maximum value that I can represent is 255. So my lowest IP address can be 0.0.0.0, and my largest IP address can be 255.255.255.255. Here all bits are 0 in each field. Here all bits are 1 in each field, in all fields. Yes or no? So guys, my all IPv4 address is going to lie in this range. Clear? My all IPv4 address is going to lie between this range. Clear? So is it a valid IP address? 0.0.0.1? Yes. Yes, brother. 0.1.0.0. Is it a valid IP? Yes. Whatever IP lie in this range, those are, guys, valid IP addresses, right? So tell me, is this IP address correct? 1.1.1. Let's say 255. Answer, yes. Yes, brother. Yes. This IP address lie in this range, na? Right? But 1 dot, 2 dot, 3 dot, 4. Is it valid? Yes. 1 dot, 2 dot, 3 dot, 256. Is it a valid IP? Not. Right? Because with the help of 8 bits, you can't write 256. Getting my point? So interviewer can write down this IP address in front of you on a page, and they can ask you, is it a valid or invalid? You will say invalid. So they can ask you why. So why this IP address is invalid? Because for each field we have only 8 bits, and with the help of 8 bits the maximum number that I can represent is 255. Yes or no? So now question is, total length of IPv4 address is 32 bits. So how many total IPv4 addresses we have, guys? 2 power 32? 2 power 32. Is it sufficient to connect everyone in the world? Is it sufficient IP addresses, guys? 2 to the power 32 means around? Yes, correct. We need more IPv4 addresses, correct? Because just see the population of world, and single people are using multiple devices. So multiple devices need IP addresses. All devices need IP addresses. And even nowadays you are using car key, so your car key is also working remotely, so they also need IP address. Your smart TV also need IP addresses. Smart bulbs are there, they need IP addresses. Your Bluetooth devices need IP addresses. A smart camera need IP addresses. But we have only 2 to the power 32 IPv4 addresses. So guys, we had shortage of IPv4 addresses. The requirement was high and availability was less. Getting my point? So what we did, we divide IPv4 address into classes to reduce the shortage of IPv4 addresses. We divide IPv4 address into classes. Okay, we divide IPv4 address into classes. Why? To reduce the shortage, because we have less number of IPv4 addresses. Now question is how we divide IPv4 addresses into classes. So we have multiple class A, then class B. Guys, please don't speak. If you are speaking or talking to anyone else, please put yourself on mute. Okay? I'm trying to make you everything from the zero, brother. Don't disturb me and don't disturb other. Right? It is going to be complicated. You know, these are fundamental knowledge. If you will not learn it, I'm damn sure after finishing ccna or ccnp, you are never going to learn IP addressing again or MAC addressing again. Right? So we divide IPv4 addresses into classes to reduce the shortage, like class A, class B, class C, and class D, even class E. Okay, on the basis of value present in first octet only. On the basis of value present in first field, you can say. Like in IPv4, we have how many field? 4 field, correct guys? 4, 1, 2, 3, 4. Right? In each field, value can be 0 to 255, 0 to 255, 0 to 255, 0 to 255. But we divide IPv4 addresses into classes on the basis of value present in first field. See, each field carry 8 bits, so that's why we are saying octet as well. Means first octet, second octet, third octet, fourth octet. This is first octet, this is second octet, this is third octet, this is fourth octet. Right? Because each field carry 8 bits. 8 bits known as 8 bits is known as 1 octet. So whenever I'm saying octet or field, both are guys same. So how we divide IPv4 addresses into classes? On the basis of value present in first octet. Now, if value in the first octet belongs to 0 to 127, that means that IP address belongs to which class? Class A. If value in the first octet belongs to 128 to 191, those IP addresses belongs to class B. If value in the first octet is from 192 to 223, that means that IP address belongs to class C. If value is from this range 2242, tell me guys, what is the range of class D? 39 to 39. And if IP address in the first octet belongs to 242, 255, that means that IP address belongs to which class? Class E. Okay. So now we have divided IPv4 address into classes on the basis of value present in first octet. So now you tell me, I'm just writing one IP address here, that is 1.2.3.4. So this IP belongs to which class? Class A? Yes. 10.1.1.1. This IP address belongs to which class? Class A. Right. 172.16.1.1. This IP address belongs to which class? Class B. Then 192.168.1.1. Which class? Class C. Okay. And guys, 255.255.255.1. This IP address belongs to which class? Class E. Okay. So as a network engineer, you are going to work on class A. You are going to work on class A, class B, class C, and you can say class D also. But generally class D is reserved for multicasting. Class D is reserved for multicasting, and class E is reserved for research center like ISRO, NASA. These organizations are using IP from this class E. So class E is reserved for research. Class D is reserved for multicasting. So when we will run the multicasting, you will see all multicast IP addresses are starting from 224. 224. So now tell me why we have divided IPv4 address into classes? To reduce the shortage. On the basis of what we divide IPv4 address into classes? Value present in first octet. Now there is one very important terms in IPv4 addressing, that is subnet mask. You know, whatever IP address you have, that is combination of two things guys, like 10.1.1.1. this is a IP address, right? This IP address is combination of two things, is combination of two things. First thing is network ID. Second thing, host ID. Host ID. Network ID means what? What is network ID? Hmm? Means it belongs to network. Yes, first IP address of the network. And host ID means last IP address of network. Right? So to know the network ID or host ID, you have to find how many network bits are there and how many host bits are there. Network bits means bit is 1. Network bit equals to 1 means bit is on. Host bit means off, means 0. This is on and this is off. Getting my point? So I need to find the network ID or host ID. First I need to find how many network bits are there, means how many ones are there and how many zeros are there. Getting my point? And guys, the tool, or you can say the marker, which we are using to specify network bits and host bit in an particular IP address is known as subnet mask. What I'm saying, what is subnet mask? Subnet mask is a tool or a marker which specify how many network bits are there and how many host bits are there in a particular IPv4 address. Clear? That is subnet mask. It is a tool which tells how many we can say ones are there and how many zeros are there in an IP address. Clear? So for each class, guys, we have a dedicated subnet mask, or you can say we have a default subnet mask. Like for class A we have one subnet mask. For class B we have a subnet mask. For class C we have a default subnet mask. So what is the default subnet mask for class A? 255.0.0.0. For class B, 255.255.0.0. For class C, 255.255.255.0. So now you tell me now how many network bits are there in class A? How many network bits are there in class A? Guys, if you will convert this subnet mask into binary, then what will be binary? Tell me the binary of this subnet mask. 81 and then correct. So how many network bits are there? Means how many ones are there? 8. Means 8 network bits are there and 24 host bits are there, right? In this subnet mask, guys, in this subnet mask, how many network bits are there? 8 plus 8. And how many host bits are there? 16, right? For class C, 24 are network, 1 2 3 4 5 6 7 8, and 8 are 0. Correct. So in the class A IP address we have 8 network bits and 24 host bits. For class B we have 16 network bits and host bits. Gaidendra, are you there? 8 host bits. Correct. Now, to find network ID of any IP address, you need to perform AND operation between AND operation on IP address and subnet mask. You can say like my IP address is 10.1.1.1. So what will be the subnet mask, guys, for this IP address? First thing, this IP address belongs to which class? Class A? Huh? Class A? So subnet mask for class A is what? 255.0.0, right? So if you will convert your IP address in binary, so what will be the binary of 10? Correct. What will be binary of 1? Again 1. Then correct. This is binary of your IP address. Fine. Then what will be the binary of subnet mask? All 1 here. 2 4 6 8. Then in second octet all 0. In third octet all. In fourth octet all zeros. Now here you need to perform what? AND operation. What is AND operation? In AND operation, if input is 0, then 0. If input is 0 0, then output is going to be what? 0. If input is 1 0, then also output is going to be 0. If input is 0 1, then also output is going to be 0. If input is 1 1, then only output will be what? 1. This is what? AND operation, right? So here we are going to perform AND operation. So guys, after AND operation, 0 1 is going to become what? 0. 0 1 is going to become 0. 0 1 again is going to become 0. 0 1 0. Here 1 1 will be 1. Then again 0 1 0. 1 1 1 and 0 1 0. Here all values are going to be 0, right? Right? Because 0 0 0 0 0 0 0 0 0 0 0 0 and 1 0 0. Here also all bits are going to be what? 0 0 0 0 0. Here also all bits are going to be what? 0 0 0. Now you need to convert it into decimal again. So decimal value of this binary is 10. Decimal value of this binary is 0. This value 0. This value 0. That means this is what? Network ID of this IP address. So if interviewer asks you this IP address belongs to which network? So guys, answer is 10.0.0.0, right? So when you are configuring this IP address on router interface, once you will assign this IP 10.1.1.1 and this subnet mask on the interface of router. Router is going to perform AND operation with IP address and subnet mask, and after that it will find network ID, and router is going to install network ID in their routing table, not IP address. Clear? Yes, that is network ID. Now let me ask you another question. Let's say my IP address is let's say this one 192.168. Let's say 10.10. So can you tell me the network ID? Classes. Class C IP address means subnet mask is going to be what? 255.255.255.0. Right guys? Now you need to convert it both into binary, correct? So whatever binary value you will get here of 192, you are going to multiply that value with all ones. So same value you will get, correct? If you will multiply 192 with 1, then you will get same value, correct guys? Here also in second field also you will get same value 168 in third octet, but here you have all bits are 0, right? So what value you will get in fourth octet? In fourth field 0. So this is what network ID. Is it clear to all how I am finding network ID from a IP address? Hmm? Clear to all? Okay, so you tell me what will be the network ID for 172.16.10.10. What will be network ID of this IP address? Subnet mask is going to be 255.255.0.0. So network ID will be 172.16.0.0. Gainendra, is it clear to you? Gainendra, are you there? Yes. Gainendra, am I audible? Okay. So hope now you can find network ID from IP address. Okay. So guys, if my IP address is 10.10.0.10.10.10, let's say, and subnet mask is not 255.0.0.0. If subnet mask is 255.255.0.0, then network ID is going to be what? 0.0. Yes. Now guys, how we get this range for classes? Like for class A, we have what range? For class A, what is the range guys? 0 to. For class B, what is the range? 128 to 191. Then range for class C is 192 to 2 to 3. How we get this range? And in CCNA, you know, written exam guys, you will get one question from here. You will get one question from here in exam as well. Question can be how many network I can design from class A. How many network I can design from class A or from class B or from class C. So just try to understand how many network bits we have for class A. We have 8 network bits for class A, correct? We have 8. Subnet mask is 255.0.0.0. That means in the first octet all bits are correct. In the second octet all bits are. In third octet all bits are. All bits are 0, right? This is subnet mask for class C. So out of this 8 network bits, I have reserved 1 bit. I have reserved 1 bit. That 1 bit will be always what, guys? 0. For class A, we have reserved 1 bit, and first bit is going to be always what? 0. Class A. This is a subnet mask, and I have reserved 1 bit. So if I have reserved the 1 bit, then how many free network bits we have? How many free network bits we have? Now 7. Free network bits are now 7, right? Because total number of network bits is 8 in class A. Out of 8 bits, I have reserved first bit. That first bit is going to be always 0. So we have rest 7 bits. So guys, if rest 7 bits are going to be 0, 0, 0, 0, 0, all 0, then what decimal value you will get? Minimum 0. If you will set all rest 7 bits as 1, then you will get the maximum value. So if you will convert it into decimal, you will get 0 here, and if you will convert it into decimal, you will get 127 here. 127. How 127? This is what? 2 to the power 7, which is 0. This is 2 to the power 6, means 64. Then this is 2 to the power 5, means 32. This is 2 to the power 4, means 16. This is 2 to the power 8. Then 4. Then 2. Then 1. So if you will add these all value, you will get 127. So how we get the range? By reserving first bit. So first bit is going to be always what? 0. First bit in class A will be always 0. So this is how I got range for class A, and my range is 0 to 127. Right? In the same way, for class B, I have reserved 2 bit. Class B, I have reserved 2 bit. By default, subnet mask 255.255.0.0, means binary. This is binary of subnet mask, right guys? So how many network bits we have here? 16. Out of 16, I have reserved 2 bit. First bit will be always 1, and second bit will be always 0. For class B, I have reserved 2 bit. First bit will be always 1, second bit will be always 0. Now how many rest bits I have? In the first octet, how many rest bits we have? Because we divide IPv4 addresses into classes on the basis of first octet value. So in first octet, how many network bits are free? 6. 6, brother, in first field. Right? So if you will set all 6 bits as 0, 3, 4, 5, 6, then you will get minimum value for class B. And if you will set all bits as 1, then you will get maximum value for class B. So what decimal value you will get here? Why 0? This is 1. First bit is 1, which is 127. 2 to the power 7. This is 2 to the power 7, na brother? Right? So you need to convert it into decimal. So decimal value will be 128. Right? Because see, the 8th bit is on, right? Means 2 to the power 7th bit is on. So here you will get what value? 128. 8. And if you will convert this binary in decimal, what value you will get? 128 plus not 64, 32 plus 16 plus 8 plus 4 plus 2 plus 1. So if you will add these all values, you will get what? 191. You will get 191. And this is how we find the range for class B. Is it clear? So range for class B is 128 to 191, not 2, sorry, 191. 191. Okay. In the same way for class class C, I have reserved how many bits? 3 bits. Class C. Submit mask 255.255.255.0. 24678. Correct? This is submit mask in binary. Then for class C, I have reserved how many bits? 3 bits. First bit will be always 1, second bit will be always 1, but third bit will be 0. Okay. So how many free bits I have, guys, in first octet for class C? Out of 8 bits, I have reserved 3 bits, so I have raised 5 bits. So if I will set 5 bits 0, then I will get what? Minimum value. If I will set rest 5 bits as 1, then I will get what? Maximum value. So what will be minimum value here? See, only 2 bits are on, 7th bits and 8th bits. 8 bits means 128 and 7th bits means 64. So 128 plus 64, 192. So minimum value over here is 192 and the maximum value 223. So you need to convert it into binary, into decimal, this value. So this is how I got range for class C. Clear? So range of class C is 192 to 223. Done. Now guys, to find number of network, you have this formula to calculate number of network is equal to 2 power n, where n is network bit. Done. This is first formula in subnetting. Number of network 2 to the power n, where n is number of network bit. So tell me, from class A, how many network I can design, brother? How many network I can design? 2 power not 8. Out of 8 bits you have already reserved 1. 2 power 7. For class B, how many network I can design in class B? How many network bits we have? We have total 16 network bits in class B and we have reserved 2. So 2 power 14 network. I can design 2 power 14 networks class B. In class C, guys, How many network I can design? Two power 21. Very good. In the ccna exam, there was one question. How many network I can design from class A? Options are 2 power 8. Option 2, 2 power 7. Option 3, 2 power 16. And option 4, 2 power 21. So which is the right answer? Class A. How many network I can design? 2 power 7. Most of the people will take this answer. They will say option 1 is correct because we have 8 network bits in class A, so I can design 2 to the power 8 network. But no guys. Okay. In the same way for class B, class B, option 1, 2 power 16. Option 2, 2 power 8. Option 3, 2 power 14. And option D, 2 power, let's say 24. So which is the right answer? 2 power 14 is the correct answer, not 2 power 16. In the same way from class C, how many network I can design? Class C, 2 power 21. Okay. Now, formula to calculate valid host is 2 to the power h minus 2. Number of network equals 2 power n, and where n is network bit. Second formula, what is happening this? Second formula, number of host, number of host equals 2 power h, 2 power h minus 2, where h is host bit, host bit. Now you tell me from class A how many network I can design? Class A, number of network 2 power 7. Very good. Number of valid host valid IP addresses. Yes. 2 power 2 power, brother, how many network bits you have for class A? 8. Total length of IPv4 address is 32. That means how many host bits are there? 24. So valid host is going to be 2 to the power 24 minus 2, right? And if I will not subtract 2 over here, that means total number of IP addresses, not valid. Valid means not including network ID and broadcast ID, means last IP address and first IP address. Because we cannot configure last IP address and first IP address on interface on an IC. So total number of IP addresses is 2 to the power 24, and total number of valid IP addresses are minus 2, right? Guys, for class B, number of networks equals 2 power 14. Okay, and number of valid host or number of total IP addresses equals 2 power 16, because we have 16 host bits. And how I am calculating host bits? With the help of subnet mask, because for class B we have total 16 number of network bits, that means definitely 16 are host, right? And total number of valid IP addresses, to the power 16 minus 2, right? And guys, for class C, number of networks 2 power 21, number of IP addresses 2 power 8, and number of valid host address, valid IP addresses equals 2 power 8 minus 2. Very good, right? So can you tell me how many IP addresses I have in class C? 2 to the power 8 is 256. 2 power 8 equals 256. Means how many valid IP addresses I have? 254 valid IP addresses are there, right? So now I am writing one IP address here, that is 192.168.10.10. So tell me, this IP address belongs to which class? Class C, right? What is the network ID? Okay, before that, what is subnet mask? What is network ID? Right? Total number of network? To power 21. And number of IP addresses? To power 8 means 256. And number of valid IP addresses? Addresses 254. Is it clear to all? Now I am designing one network. I am designing one network for, let's say, one department, right? For guys, I am implementing one network in a building, right? And I have around 100 number of PCs or end devices users. So I need how many IP addresses? 100 number of IP addresses. One for one device. One for one device. So if I am using this network 192.168.10.0 and submit mask 255.255.255.0, that means I am wasting how many IP addresses here? 154. I am wasting 154 IP addresses, right? By the way, you have already shortage of IPv4 addresses, and now you are wasting around 150 IP addresses here, right? So in the class C, even we have less number of IP addresses, guys. In class C, you can see we have only 2 to the power 8 IP addresses. In class B, we have 2 to the power 16 IP addresses. In class C, we have 2 to the power 24 IP addresses, right? So if your network size is small, then you are going to use network from which class? Right. If your network size is medium, then you are going to use network from which class? And if your network size is very large, then you are going to use network from which class? Class A, right? But still, in class C, we have 256 IP addresses, right? So what for a small networks, guys, where I need, let's say, only 20 IP addresses or 50 IP addresses or 100 IP addresses? What about those type of network? Every time I will waste lots of IP addresses, right? So to reduce this wastage, we come up with subnetting. So subnetting is nothing but dividing a large network into a smaller network. See, if I will talk about this IP address, I'm erasing it. Do you guys need this information? Can I save it? Save it. Okay. Now, let's suppose I have this IP address, this network 192.168.10.0 and submit mask 255.255.255.0. So can anyone tell me the first IP address? 192.168.10.0. Second IP 192.168.10.1. Third IP 192.168.10.2. Fourth IP 192.168.10.3. Last IP address will be what? 192.168.10.255, right? So this is my first IP address, first IP address, and this is, guys, last IP address, last IP address. First IP address is known as network ID and it is not usable. Last IP address is known as broadcast ID, again which is not usable. That means we cannot configure last IP address and first IP address to device. That means first usable IP address is this one, 192.168.10.1. So what will be the last usable IP address? 192.168.10.254, right? First usable IP address, and this one is last usable IP address. Okay, so we have total 254 usable IP addresses in this network. Correct, guys? So still network size is large. We have 254 IP addresses, but let's suppose I need only 100 number of IP addresses. Then what we can do? We can divide this large network into two part, or into four part, or into eight part according to our requirement, with the help of subnetting. So what is subnetting? Again, subnetting is a tool which is used to divide large network into a smaller network. Okay, and always keep in mind, as I'm saying, network ID is the first IP address and broadcast ID is the last IP address. So guys, your broadcast address tells where your network is ending, and your network ID always tells you from where your network is starting, from your from where your network is starting and where network is ending. So network ID represent a starting point from where my network is starting, and broadcast ID tells where my network is ending. And in this network, let's say there is one user who is using this IP address 192.168.10.3. So what is the broadcast address for this address, guys? This one, last IP address of this network. So if this user need to forward a traffic to everyone in the network, it will forward that message to this address. It will forward that message to this address, because this is the broadcast address for this network. Okay, so if I need to send one message to everyone in the network, I will send it to broadcast address. Okay, so in the configuration, when I will configure routing protocols or switching protocol, you will see whenever device is sending the broadcast message, whenever a device will send broadcast message or the device, it will forward that message to this address 255.255.255.255. This is what last IP address of the IPv4. That means broadcast for all network. This IP address is the broadcast IP address for this network only, right? But this is the broadcast address for all IPv4 network. In the same way, if I will talk about the broadcast MAC address, so what is the last MAC address, guys? All F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times F. So this is what? Broadcast MAC address. Broadcast MAC address. So if you want to send a message to everyone in your LAN network, you can send that message to this address, right? All app means broadcast MAC address. All 255 means broadcast IP address. So always keep in mind, if someone will ask you what is broadcast MAC address, guys, broadcast MAC address is 12 time F, and broadcast IP address is 255.255.255.255. Broadcast IP address. Yes. IP means IPv4, right? So is it clear? Is address is clear, guys? So that tomorrow I can start submitting. Okay. So topic for tomorrow is submitting. But before starting the submitting, make sure you will revise these all concept, right? If you will have any doubt, even you can let me in the chat, guys. Before starting the subnetting, you have to clear your IPv4 and MAC addressing concept. If you are lacking in IPv4 addressing, you can't understand subnetting, and you can never understand the real-time requirement for IP address planning, right? So in the real time, guys, whenever we are designing a network, it is very important to plan IP schema, how we are going to use IP addresses. Okay, because IP address is going to define the performance of network, security of network, right? Scalability of network, means you can increase the size of your network according to requirement or not. Okay, so if your network size is large, it is complicated to troubleshoot. If your network is small, it is easy to manage, troubleshoot. More secure, a small network is more secure as compared to large network. Okay, so that's why we have subnetting, guys, to divide large network into multiple smaller network. Now if anyone have question, please ask. So in this network, let's say here I have some PCs, like this. Let's say here I have 100 users. Here I have 100 number of users, and here also I have 100 users. So if you will use network from class C, that means you are wasting 154 IP address over here in network 1 and 154 IP address in network 2. So now you can access the router and you can try to configure IP address. For now, guys, just I am telling you the command to configure IP address on router. See, once you will access the router, you all know how to access router in packet tracer. Once you will open the packet tracer, guys, in the left bottom you can see the devices, and first device is networking devices. So once you will click on networking devices, you will get lots of routers. For now, just use this last router, 2811 series router, this router, right? So just drag and draw this router in the workspace. After that, right click on the router and then take CLI. Here you can see command line interface. So take CLI. Once you will take CLI of this router, you will get this option. So for now, just type no here. What you will type first? No. After typing no, you will get access router in this mode. This is user mode. So first of all, you need to run enable command here. So just type en and then tab button in your keyboard. So once I will type tab button, it will automatically detect the command. Whatever commands are there, which is starting with en, it is going to detect. So there is only one command, guys, so it have detected. So enable, let me hit enter. After that, I'm going to run configure terminal command, right? Again, I am just typing con, then tab, conf. See, I am typing con and then tab. Tab is not working. Why? Because there are multiple commands with con. So I am saying f, and now if I am typing tab button, see, it is detecting the command. Then T and tab, so terminal. Then I need to configure IP on interface, so I will type interface, then interface type. So interface type is fast Ethernet, so say fast Ethernet, and then interface ID 0/0. So like on router number 1, let's suppose here my network is 192.168.10.0, subnet mask 255.255.255.0. Here my network is 192.168.20.0, subnet mask 255.255.255.0. So can you configure these two network on router, on this router? Yes. How you will configure? Simply first enable, then configure terminal, then interface type is fast Ethernet, it can be Giga Ethernet, it can be Ethernet, right? So fast Ethernet, after that interface type is 0/0. So as I told you, by default router interfaces are down. So first of all you are going to run command no shutdown. No shutdown. So once I will run no shut command, you can see my port status is changed to up, and even line protocol of this interface change state to up. Their line interface is also up, means what? Switch interface is also up, right? Now I can configure IP here, so I can say IP address. After that, tell me the IP address. What IP address you want to configure? So 192.168.10. Let's say 1. Can I configure 10.0? 255.255.255.0. Can I configure this IP address? No. Bad masks with /24 for address this one. Why? Because this is not valid IP address. This is network ID. Correct, guys? So I cannot configure the network ID and broadcast ID. See, IP address 192.168.10. What is the broadcast address of this of this network? 255, right? 255.255.255.0. So first I am defining IP address, then I am defining subnet mask. Okay, can I configure this? No. Why? Because this is bad subnet mask, because this is broadcast ID. But can I configure this IP 192.168.10.1? 255.255.255.0? Yes, because this is a valid IP address. Now I have us, yeah, yes. No, no, brother. That means, you know what? I have configured this IP address over here. Now router is going to perform AND operation. It will convert this IP address into binary and this submit mask into binary. After that, router will perform AND operation, and then it is going to install that network in their routing table. So IP route. See, in the routing table, which network is there? 192.168.10.0. Directly connected on fast Ethernet 0/0. What it's saying? This router is telling you that this network is directly connected on fast Ethernet 0/0. So how router have calculated the network ID with the help of AND operation. So now router is going to maintain that this network is connected on 0/0 interface. So whenever I will receive traffic where destination will match in this network, I will forward that from 0/0. This router will forward that traffic from 0/0. Right? So that is how router is going to install network in the routing table, right? But if I want to ping the router, let's say from PC0, from this PC, I will not ping to network ID, na? I will ping IP address which is running on router. So the IP address which is running on router is 192.168. Let's say 10.1. Sorry, 2 is the IP address of this PC because 1 is already configured. 192.168.10.2. Subnet mask 255.255.255.0. So if I will ping to router, open CMD and say ping, and the IP address of router is 192.168.10.1. You can see ping is working. I am getting the reply message, right? but I cannot ping the network ID. Ping 192.168.10.0. I'm getting the reply. Yes, I'm getting reply, brother. See here. Sorry, network ID is also working and IP address is also working. Who is generating reply? This is, because of some configuration on router. Who is generating reply, guys? Router is generating reply. This is because of some configuration on router interface. We will discuss about this configuration also. See, if I am pinging to network ID, it is generating ICMP, it will forward to switch, switch will forward it to router, and router is generating route reply. And what is happening? See one more thing. When I am pinging to this network ID, just wait, let it finish. Okay, now let me open the simulation again. So when I am pinging the network ID, what this PC need? See, when you are pinging to a particular IP address, PC need MAC address of that IP address, correct guys? But this time, I am pinging to a network ID. What will be the destination MAC address? Destination MAC address is going to be broadcast. See the layer 2 information. Destination MAC is all F. And destination IP address is what? Broadcast. So you are not pinging to network ID. Actually, you are pinging to broadcast ID. So this is why you are getting reply message. Everyone in the network will generate reply. So as I told you, if you want to send a packet to everyone in the network, you will forward it to broadcast address, right? So when I'm pinging to a network ID, it is pinging to broadcast. Actually, this PC is thinking that you are trying to send it to all users in the network. That's why it's sending to broadcast address. Correct. This is the configuration on PC, na brother. I told you, na. This is because of configuration on PC. This is behavior of operating system. This is behavior of this PC operating system. Even yeah, even you can ping to this IP address also, your broadcast address. Let me assign one IP on this PC also so that I can show you this PC is also generating reply message. If destination is broadcast, then all PC will generate reply packet. Correct. See, I can ping 192.168.10.255. This is my broadcast address. I'm getting reply. See, I'm getting lots of reply, right? Because all devices are sending reply message this time. So if you will count the reply, so actually when we are running this command, ping command, guys, your PC is generating 4 ICMP packet. See, earlier you had how many reply messages? 2, 4, 5. So this time how many reply message you will have? 5 from router, 5 from PC3, 5 from PC2, 5 from PC1. So 20 reply messages are there. Right? And if you want to see it, simply you can use simulation mode here. Ping to this IP address. Let me open the ICMP. See, still this PC is sending traffic to 255.255.255. This is behavior of operating system. उस पे नहीं भेजेगा ना, ये इसके ऑपरेटिंग सिस्टम की कॉन्फ़िगरेशन ही ऐसा है ना कि अगर आप अपने नेटवर्क की ब्रॉडकास्ट आईडी को भी पिंग करते हैं तब भी ये जो IPv4 का ब्रॉडकास्ट एड्रेस है उसी पे ट्रैफिक भेजेगा. नो, no, from PC, let me try it from the router. Ping 192.168.10.255. Here also destination is all F and 255.255. No, we cannot see the broadcast address. Broadcast address of that particular network. It will always send to 255.255.255.255. The use of that broadcast ID is you can identify the last IP address of your network. You can inform to your employees that whenever you want to forward traffic to everyone, you should forward it on this IP address. This is your broadcast address. And it is indicating actually the last IP address only, right? The last means where my network is ending. Right? So see, it is forwarding to broadcast address means all PC will generate reply message. So see guys, all PC have received the request and all are generating reply. Okay. See the latency here, delay, because it is receiving reply from all PC. Interface F0/0 IP address 192.168.10.125.255.255.128, let's say, and let me say ping 192.168.10.127. Still destination is 255.255.255.255. So we cannot see the broadcast address of my network. Broadcast address is going to be 255.255.255.255 means broadcast address of IPv4 address. Last IP address of IPv4 address. But see one interesting thing guys. When any PC is sending broadcast message, right? Router is not forwarding that broadcast message from one interface to other. Even you can configure this interface also on the router interface F0/1 cnosat and IP address 192.168.20.1255255.255.0. Done. ping 255.255.255.255. 192.168.10.255. It will forward to all device. Will router forward this broadcast message from their other interface? Answer is no. So always keep in mind, router cannot forward broadcast message from their one interface to other interface. Actually, in this scenario, router is dividing the broadcast domain. Guys, broadcast means one to all in network is known as what? Broadcast. And there is one more concept, that is broadcast domain. Broadcast domain. Broadcast domain means what? Area. Broadcast means one to all. So a domain or an area where broadcast message can be travel is known as what? Broadcast domain. Domain where broadcast message can be travel is known as broadcast domain. So in this scenario you have two broadcast domain, right? Router divide broadcast domain. So this is a separate broadcast domain and this is a separate broadcast domain. Means broadcast message of this network cannot travel in this domain, and broadcast message of this domain cannot travel in this domain, right? So all ports of switch belongs to single broadcast domain, but router has per port broadcast domain, right? So let's say if PC0 want to communicate with PC3, right? So PC0 need MAC address of PC3, so it will generate ARP, and ARP is a broadcast message, guys. Will PC4 receive that broadcast message? No, because router is not going to forward it. This is in different broadcast domain, this is in different broadcast domain, right? Let's say broadcast domain 1, broadcast domain 2. So broadcast message of broadcast domain 1 cannot travel in broadcast domain 2. No. So it have to send unicast message, na? PC0 to PC4. Now question is, how PC0 can resolve MAC address of PC4? Because to resolve MAC address, PC need to generate ARP, and ARP is a broadcast message. Getting my question, guys? So this is your question. Tell me the answer tomorrow. How PC0 can communicate with PC4? Because PC0 need MAC address of PC4, and to find MAC address from IP address, we need to call ARP protocol. ARP protocol generate a ARP request message which is broadcast. So PC will forward that broadcast message to router number 1, but router will not forward it to PC4. Then how these two devices can communicate with each other, guys? Anyone have idea? What IP address? Brother, IP address of PC0 is 192.168.10.1. IP address of PC4 is, let's say, 192.168.20.1. So when I will type command ping 192.168.20.1 from this PC, this PC will generate one ICMP request where source IP will be 192.168.10.1. Destination IP will be 192.168.20.1. Then this PC need to add Ethernet header, as I told you, as we discussed in last class. In last class, what we discussed, that now Ethernet protocol is going to add Ethernet header, and Ethernet header, it will add source MAC and destination MAC. So source MAC will be the MAC address of PC0. What will be the destination MAC? Destination MAC should be the MAC address of destination device. So no. See, destination MAC is unknown for PC0, right, guys? Unknown. So PC0 need to find MAC address of 192.168.20.1. But can PC0 resolve MAC address of this IP address? Never, because both are in different broadcast domain. So whenever destination belongs to different network, see, once you will ping to this IP address now 192.168.20.1, this PC is going to check that this IP address belongs to my network or different network. So my IP address is 192.168.10.1. My subnet mask is 192.1. Sorry, my subnet mask is 255.255.255.0. That means my network ID is 192.168.10.0. Destination IP address is 192.168.20.1. That means destination network is 192.168.20.0. Now this PC is going to forward traffic in different network, correct guys? Destination belongs to different network. I am in different network. So whenever destination is in different network, in that scenario, destination MAC will be the MAC address of my default gateway. Now there is again one, yeah. Now again there is one concept like what is default gateway. So leave it for now. We will discuss these all later, okay? So that's all guys for today. Let's meet tomorrow now, and we will